Hello everyone. Today we're gonna solve the replace words problem. This is an updated version of the previous element, right? The prefix tree data structure. If you haven't seen this video yet, I highly recommend you to watch this video before trying to solve this problem. I will leave the link below on the right side at the end of this video. You can check it out. So to summarize this problem, we're gonna have a dictionary of some words, and we're gonna have a sentence which can contain, which have a lot of words, and some of the words can have the prefix in the dictionary, and we can replace those words by their prefix. So for basically, we can replace the kettle by cat, or we can replace the battery by bath, or we can also replace uh, rattle by rat. And the new sentence gonna be, we have a new sentence gonna be this, but we will replace each of the word by their shorted prefix. Three. Perfect. So, and this problem asks us to return the new sentence after we replace each of the word by their shorted prefix. And how can we do that? Basically, if we have a dictionary like this, we can have a prefix tree like this. We have a root right here, and we have C, A, T, and this is the end of the word. And we have E, oops, A, T. This is the end of the word. One is R, A, T. So if we implement the try the prefix tree data structure, we're gonna have something like this. And for each of the word in the sentence, we're gonna find a path of this one. We're gonna find the prefix of each of the word for this one. For example, for the, we don't have any t right here, so we cannot replace the first letter. And for cattle, we have cat, and this one is the end of a prefix, so we can replace the at by we can replace the cattle by cat right here. And then continue for words, we don't have any w right here, so which means that we cannot replace this one, so we're gonna keep it the same right here. And for rattle, we have r right here, we have a right here, and we have t right here. And we can see that this one is the end of a prefix, so we can replace r a t to rattle. So we have rat, we have rat right here. And continue, we have by. For b, we have b right here, but we don't have the y right here, so that's why we cannot replace the by. So we're gonna keep it the same right here, and same for the right here. And for battery, we have BAT. We saw that T is the end of a prefix, so we can replace AT to battery. So that's basically the idea. And this is the same for the second one. We're gonna have root right here. We have 8, E, we have C, which also the end of the prefix. And for each of the word, we just replace this one by A. This one, we can see that A here. This one is B, and this one is C. So that's all the idea for this problem. But you haven't, if you haven't watched the prefix tree, you should watch them so that you can know how to implement it. So now we will implement it again for prefix tree. First of all, we have 26 letter. Let me double check it again if we just have only lowercase letters. Yeah, we only have the lowercase letters. So we have mash. This is 26 or 26 letters. And we're gonna have a class Mike, and we're gonna have a class of try node right here. Yep. And for the try class, we're gonna have a root node right here, and we're gonna have a constructor for right. So for the constructor, basically we just need a root node, new try node right here, and we're gonna have I think we don't need to search for a word. We just need for a shorted. We just need to look for a shorted prefix in this try data structure. So we just need two function insert and a function called get shorted prefix for a word, right? So that's basically the idea. And we will insert a word here. Yep. I think that's all for the try uh, class. And for the try node, we're gonna have two function as usual. Function to get a new node, get the next node. We have a function to create a node, and then we're gonna have a flag called end of the word and next node for 26 letter. All right, that's all for the skeleton. And at first, we're gonna insert all of the word from dictionary to our try our prefix data structure, prefix tree data structure. So first of all, we're gonna have my first, and we're gonna insert for the dictionary our try data structure. Okay, and we're gonna look through all of the word in dictionary, and then I dot insert word, all of the word, and then the second step should be for each of word in our sentence, we're gonna uh, we're gonna replace each of the word by their shorted prefix. So go through each the word, then place by the short prefix, shorted prefix. Okay. And first of all, to look through each of the word in C++ is gonna be harder to compare with other language like Python. So I'm gonna use a string stream right here for the sentence. Then I'm gonna split all of the word in this sentence using string stream. I'm gonna have a new sentence. Then gonna have a first space, in the first space, so that we can insert a space between each of the word. First of all, it's gonna be 4 because the first word doesn't have any space. Then we have a string for our current word we consider. Then we're gonna push each of the word in our sentence to the current word right here. And then we're gonna uh, consider a root of the word on the shorted prefix of the word. And then we just need to call the get shorted prefix, get the prefix of the current word, and then if we have the first space, we just get the space in our new sentence, and we get new root of word. Then we decide the space gonna be next one, and finally we just need to turn sentence right here gonna be. Okay, that's all for uh, the main function, but we need to implement for the rest of the function. So first of all, we're gonna implement the get next node right here. I think we're gonna go to the top-down approach. One is third function. We're gonna current node. Then we're gonna move to each of the character in the word, and we have if the current get next node is pointer, not a non pointer, we do the next one. And else we're gonna need to create a new node. Next node. Then we're gonna assign the end word right here. Yep, that's all for the insert function. And now we're gonna get next node and create next node function. Get next node one, we're gonna have this one is to convert a e to 0 to 26, 25, so that we can use an array, a static array, to represent it instead of using more complicated structure like hash map or another map in plus. And then we just need to turn next of it, this one. And we're gonna create a new node. And then we're gonna assign the next of digit equal to new node. And we're gonna here. Yeah, that's all for the insert operation. And now we're gonna go to the very important operation in this problem to get the shorted prefix. So first of all, we're gonna get the current node first, be the root, and then we're gonna have to go through each of the word in each of the character in current word. in current word. Check whether or not we can get a path to this letter, get next node letter. If we can, if we already have a path, which means that we can move next one, right? We're gonna do this here, and else we're gonna do this one. Let me see if we even okay. We're gonna just need to fix the equal to plus with C, and if we found the current, if we already found a prefix, we just need to return the current prefix, because if we move further, we're gonna get a longer prefix, because this one said that if we have more than one root, we just need to replace it with a root that has the shortest length. So if we already find uh, the prefix right here, we just need to return prefix. Then we return. At the end, we can just return word right here. Fix right. This actually we can click right here. Yes. Have space. Plus space. Right. Now we have the time complexity would be the number of character is number of character, then the number of letter in our dictionary plus with the number of letters in our sentence. And for the space complexity, it's gonna be the same thing. We're gonna have number of letter in dictionary, or basically it's just number of nodes we use. And it's the same thing with this. And the topic for this one is try on prefix tree and pointer and string post. Yeah. Let's see how it goes. I have a try, and then we have my class to get a node, and and to get the shorted part right here. I think this one looks good. Get the shorted. Good. Okay. Line change this Get current node. I think found the yeah, I found the error. Right. Perfect. And that's all for this question. And again, if you haven't seen the videos for to implement the trie data structure, the prefix tree data structure, I will leave it below the right side at the end of this video. Thank you.